Hello friends, today we will see what is mean by degrees of freedom, its effect and how to know a degrees of freedom. So let's start. Now here we will take one small example. Suppose this is one geometry which is attached to the fixed support at this point. There is one point P on which force is acting and there is one more point Q. So when there is application of this force, this body will try to move in the another position. So this red color indicates a position after the action of this force. This point move from here to here. This P point move from P to P dash and this Q point move from Q to Q dash. In this space, so how to locate these points P, Q and these support points? So here we need degrees of freedom. So what degrees of freedom indicates? It is the minimum number of parameters like motion, coordinates, temperature. Means for this example, these are the coordinates which can be defined here so that we can find out exact position of these points. Means minimum number of parameters required to define position of any entity completely in the space is known as a degrees of freedom. Means this is an entity which can be defined with the help of coordinates to get the exact location of that entity. That is called as a degrees of freedom. It is also short form known as DOF. So how it is necessary in finite element analysis we will see. Suppose here I am taken one example which is having 4 elements 1, 2, 3, 4 and it has 8 nodes 1, 2, 3, 4 and these 4. So total number of nodes is 8. Now degrees of freedom is at each node is 6 degrees. So how it comes 6 we will see later on. So let's assume for each node we have 6 degrees of freedom. Means we will get for a single node we will get 6 equations. So in this system there are total 8 nodes and this is 6 degrees of freedom for each node. So total number of equation we need to solve here is 8 multiplied by 6, 48. So the boundary conditions and the constraint which will reduce means in this system if we have boundary which will reduce the number of degrees of freedom at that node and which will reduce the number of equations. So maximum possible we have to solve is 48 equations. Now we will see how to find out the degrees of freedom. Now let's take one plane in the xy plane. There is one point A which is defined by the coordinates y1 and x1. So x1 indicates it is a horizontal distance, y1 indicates the vertical distance. So two parameters like coordinates, these are the two values of the coordinates which required to define this point A in the space. So we can say that we have 2 degrees of freedom. That is translation in x and y. Means due to the action of force, this point can move in the x direction as well as in the y direction. So it is known as a 2 degrees of freedom. Now we will move further. In the same plane, we will have one line. So this line we can define for this point A, we define x distance, that is horizontal distance, and y distance in the vertical distance. And third parameter we require here is we have to find out the what is the angle made with the horizontal, so that we can define this line where it is. So we need x1, y1 and the theta x means the angle made by this line. So we can say that it has 3 degrees of freedom, that is translation in x and y and rotation in theta direction. Means if we apply some forces on this line, this point can move in horizontal direction or vertical direction, or it can rotate in this theta direction. So these are the 3 degrees of freedom. Now we will take same line in the 3-dimensional space, that is x, y, z. So if we want to define this line, we need x1, y1 and z1. Means the x coordinate, that is horizontal, y coordinate, that is vertical, and the z coordinate in the z direction. So 3 coordinates, as well as we need theta x, means angle measured by to this x axis, theta y angle which is made to y axis, and the theta z angle made to the z axis. So we need maximum 6 degrees of freedom. That is, when we apply some force on that line, it can move in x, y, z, that is translation motion, or it can rotate in x, y and z direction, that is rotational motion. So if we constrain some body, means if we fix this point, so so we can take x or y as a 0. So maximum possible number of degrees of freedom is 6. Due to the boundary conditions and the constraint, it will further reduce to 4, 5, 3 or 2, or it may be 1. But if it is 0, then in finite element analysis we don't have an equation to solve, so it is called as a rigid body. So at least it should have 1 degrees of freedom or maximum 6 number of degrees of freedom at each node.